Hello everyone and welcome to Geometry Lesson 2-4, Vertical Angles. Vertical angles are used a lot in geometry because they occur anywhere two lines intersect. This also happens to be my favorite type of angle. They're pretty easy to work with, so you just might come to love them too. Can't stand the anticipation? Okay, let's get started. Anytime two lines intersect, they make four angles. Mathematicians have learned that there are two special types of angle pairs at each of those intersections, and the relationships between those angles are always the same. Vertical angles are the two non-adjacent formed by intersecting lines. Simple, right? Well, maybe not. Let's look at that definition. Hopefully you got the intersecting lines part, and you know we need a pair of angles, but let's review that word non-adjacent. Remember, adjacent angles are angles that have a common side. They share a ray. Then non-adjacent angles have only their vertex in common, no other points. So vertical angles are kind of the angles that point to each other. They don't have anything in common other than that vertex. A linear pair, though, are the pairs of adjacent angles whose non-common sides are on the same line. In other words, when I have two lines that intersect, the angles across from each other, like angles 2 and 4, are vertical angles, and the angles next to each other, like angles 1 and 2, are linear pairs. So let's classify each pair of angles we have in this intersection. So I know angles 1 and 2 are a linear pair. Angles 2 and 3 are adjacent, so they're a linear pair. 3 and 4 are adjacent, they're a linear pair. And 4 and 1 are adjacent, so they're a linear pair. Then the ones that kind of point to each other or are across from each other, like angles 1 and 3, are vertical angles, and angles 2 and 4 are vertical angles. So let's see what kinds of relationships these angles have. First, the linear pair postulate. Think about a line. What other name could we give a line? Did I hear you thinking a straight angle? Right. A line is really just a straight angle, which means it measures 180 degrees. What else do you know? Think about our last lesson. That equals 180 degrees. Supplementary angles? Wow, you're on fire. Great work. So if I know that in a linear pair, the angles come together to form a line, and that line measures 180 degrees, then the angles in the linear pair are supplementary. That was a really great informal proof. We'll learn more about those in the next lesson. The linear pair postulate tells us that if two angles form a linear pair, then they're supplementary. Using our picture, I can write out what this would look like algebraically. Let's use angles 1 and 2. Since I know they make a linear pair, I know that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. We could do this for each one of those pairs that we talked about on the last page. Now for my favorites. Let's move on to vertical angles. The vertical angles postulate. This is my favorite postulate in all of geometry. If you remember these four words, you'll be off to a great start. Here they are. Ready? Vertical angles are congruent. Do you remember what congruent means? That just means that the angles have the same size and the same shape. The measure of two vertical angles are always the same. Then for this picture, I could write that angle 1 is congruent to angle 3, or that the measure of angle 1 equals the measure of angle 3. The same is true for angles 2 and 4. All right, time for some practice. Let's see if you can pick out the vertical angles in linear pairs. In our first picture, angles 1 and 2 are formed by the intersection of two lines. They're adjacent angles, sharing a side. That makes them a linear pair, and therefore supplementary. What do you think about our next example? These are two non-adjacent angles that share the same vertex, but are they vertical angles? If you said yes, you're not alone, but you're also wrong. Vertical angles have to be formed by two intersecting lines. If I extend the rays that make up these angles, they don't continue on to be the same line like in the last example. So then these two angles would be classified as neither vertical angles nor a linear pair. Make sure you've always got two lines that intersect anytime you're making vertical angles. Now let's try and apply those postulates to a few problems. In our first example, we're looking for the measure of angle RSU. First, classify the angles. Since they're adjacent angles formed by a pair of intersecting lines, I know this is a linear pair. The linear pair postulate tells me these angles are supplementary, which I remember from our last lesson means that they add up to 180 degrees. So if I subtract 66 from 180, I get 114 degrees, the measure of angle RSU. For you algebra fans, this would look like the measure of angle RSU plus 66 equals 180. Then solve the equation for the measure of angle RSU by subtracting 66 from each side. Next problem. Angle CED is here, non-adjacent to angle AEB, my given angle, but still formed by the same pair of intersecting lines. So these have to be vertical angles. Time to recite your new mantra. Vertical angles are congruent. So then angle CED is congruent to angle AEB, so it has to measure 54 degrees. The next problem requires a little bit more algebra. I can see that these are both vertical angles, so I know that they're congruent. That means their measures have to be equal. So if I set the expressions equal to each other, then I'll just solve it. 4y minus 48 is one angle, and 2y is the other. So my equation will be 4y minus 48 equals 2y. Subtracting the 4y from both sides leaves me with negative 48 equals negative 2y. Dividing both sides by negative 2 leaves me 24 equals y. This problem is another great example of how we use geometry to set up a problem, but then we find the answer using algebra. Let's try one more of those before we move on. Angles 1 and 2 are a linear pair. I know that angle 1 measures 84 degrees, and I'm looking for angle 2. A lot of times, geometry problems will be written out like this. When I'm doing these problems, my first step is to draw a picture to help me visualize the problem. I need a linear pair, so that's two intersecting lines, and I'll say this is angle 1 and this is angle 2. Now I know that angle 1 is 84 degrees, so I'll write that out, and I need to find the measure of angle 2. I know these two are supplementary, so I'll just subtract 84 from 180 to get my answer of 96 degrees. Algebraically, that's measure of angle 1 plus the measure of angle 2 equals 180, 84 plus the measure of angle 2 equals 180, and then subtract 84 from both sides, so the measure of angle 2 is 96 degrees. Alright, now let's try some true or false. These kinds of questions are really important to geometry because they're a great way for me to test and help you use that basic logic that we've been learning. So in our next two examples, we have a picture here that shows two intersecting lines, and they've made angles 1 through 4 as they're shown on there. Our first statement says that if the measure of angle 1 equals 44 degrees, then the measure of angle 2 has to equal 136 degrees. The statement is implying that angles 1 and 2 make a linear pair. In the diagram, angles 1 and 2 aren't adjacent angles, so they can't be a linear pair. These two are vertical angles. So if the measure of angle 1 is 44 degrees, then the measure of angle 2 also has to be 44 degrees. The final example for today asks whether it's true that angles 1 and 2 form a linear pair. We just discussed this while completing the last example, and we decided that angles 1 and 2 were vertical angles. So vertical angles can never be a linear pair, so this one is also false. That's all for today's lesson. Remember, you can go back and review any parts of the lesson that you didn't understand. Thanks for joining me, and happy hypothesizing.